Hello, can you solve this interesting problem? The speed of a motorboat is 9 meters per second on a still water. When a motorboat was sailing against a river flow of 3 meters per second, a boy dropped his ball in the river. His parents noticed that the ball was missing only after they sailed 3 kilometers. They turned back and reached the ball. How much time did the motorboat take to reach the ball from the moment they lost it? When you try to solve this problem, you should not forget to consider when the ball was dropped to the water, it was floating together with the river flow. Now you better pause the video to try to solve this problem by yourself, because from next time I'm gonna give you the solution. Okay, let's start. First, let's write what we know and what we need to find. We know that the speed of the motorboat on the still water is 9 meters per second. We know the speed of the river, 3 meters per second. And we know the distance from the moment the ball was dropped to the river to the moment when they find out the ball was lost and they turned back. And we need to find the total time from the moment they lost the ball to the moment they found the ball. So this is what we know and what we need to find. So the total time consists of two times. It's the time they left the ball and the time they returned for the ball. So first let's find the time they were leaving the ball. When the motorboat was leaving the ball, it was sailing against the river flow. That means the speed of the boat was slowed by the river flow. Then we can find t-lift by this formula. S divided by Vm minus Vr. So if we put these values to this fraction, we are going to get this fraction. And if we divide numerator by denominator, we are going to get the 500 seconds. Now let's find t return. In this case, the motorboat was going together with the river flow, so their total speed will be summed. So we can find the t return by this formula. In this formula, we know S, we know Vm, and we know Vr. But we don't know the distance that the ball was floating together with the river. But we can write that it is equal Vr multiplied by t total, because the ball was floating with the speed of the river, so that's why we have a Vr here, and it was floating the total time from the moment they lost the ball to the moment they reached it. So now let's put the values we know in this fraction. Then we'll get this fraction. I didn't use the units, meter and meter per second. Anyway, they are all meter and seconds, so I just wrote the actual values. Now let's put t leave and t return to our first formula. Then we'll get this equation. Now let's multiply this equation, the left side and the right side, by 12. Then we'll get this equation. So 6,000 plus 3,000 will be 9,000. And we also can subtract the both sides of this equation by 3t total. Then we'll get this equation. From here we can simply find the t total. It is 9,000 divided by 9. And it will be 1,000 seconds. That's the answer. Since the total time equal 1,000 seconds and t leave equal 500 seconds, it means that t return also equal 500 seconds. So that means that t leave equal t return. And this problem could be solved in more easier way if you could logically prove that t leave equal t return. But in this case I decided to solve it mathematically. Thank you for watching. Subscribe for more physics videos.